Take a second and look at the chair you're sitting in right now. I mean, really look at it. You might not realize it, but that everyday object is actually a profound feat of engineering. Welcome to This Explainer. Today, we're tracing a totally fascinating evolution, starting from the heavy, machine-age metals of the early 20th century all the way to modern green biocomposites. It's really a story about how industrial innovation completely changed the physical shapes we interact with every single day.
This quote right here perfectly captures the core theme of what we're talking about today. Iconic design, it is never just about making things look pretty. It's about consciously throwing away the rulebook and truly mastering the manufacturing process. You literally can't break the rules of form until you fundamentally understand the physics and the machinery of the materials you're working with.
So here is our roadmap for today. 1. Mastering metal and manufacture. 2. The mid-century plastic revolution. 3. Ergonomics and modular systems. 4. Pushing the limits of form. And finally 5. The sustainable design frontier.
This timeline maps out the massive 80-year paradigm shift we're about to dive into. We are looking at a rapid acceleration of human ingenuity here. We go from the cutting-edge metalwork of 1931 straight through to the mass production techniques of the 60s, right up to the revolutionary, eco-friendly biocomposites of the 2010s.
Let's jump right in. Section 1. Mastering metal and manufacture. The foundations of heavy metal forming.
So, looking back at 1931, Jean Prouvé's Cité armchair immediately anchors us in an era where dynamic visual language was the direct result of advanced metal forming. Prouvé was one of France's top designers, and he used his architectural metal engineering background to create this completely radical aesthetic. I mean, it doesn't look like traditional furniture, mostly because it wasn't built like traditional furniture.
Instead of traditional carving or basic wood joinery, Prouvé basically treated the chair like a small building. He didn't carve wood, he stamped, pressed, and welded steel. By welding 4 separate sub-assemblies together and using powder-coated finishes with integrated connection fittings, he gave the chair this insane structural integrity. The visual style you see is purely a byproduct of the cutting-edge manufacturing processes of the time.
Moving on to Section 2, the mid-century plastic revolution, mass production and the injection molded boom.
This side-by-side comparison brilliantly illustrates a massive leap. On the left, you've got the Eames fiberglass design, which became a total cultural icon. But on the right, Robin Day's 1963 chair represents a massive pivot. That's a single injection-molded polypropylene shell. We're jumping from complex, multi-step fabrication straight into rapid, single-piece mass production.
Now here's the real kicker. While fiberglass was visually groundbreaking, it was actually a super slow and expensive process to finish. Thermoplastic injection molding, on the other hand, required a massive initial investment for the tooling. But once that tool was paid off, wow. It ultimately revolutionized the entire industry. It made ultra-tough chairs phenomenally cheap, lightning fast to produce, and incredibly profitable. This is basically the archetype for the indestructible seating we all remember from our school cafeterias.
All right, Section 3, Ergonomics and Modular Systems, adapting to evolving human and workplace needs.
When you compare the pioneering 1968 Action Office system with the 2006 current series, it really shows exactly how modular furniture had to race to keep up with workplace tech. These systems suddenly had to maximize cable management and flexible panel zoning just to quickly accommodate the computer age and constantly shifting open-plan workstations.
But hey, modularity isn't just for the office, it's for human growth too. Just look at Peter Opsvik's 1972 Trip Trap chair. This is so smart. It relies on a brilliant system of horizontal fluted slots and physical compression to allow the seat and footrest to dynamically adjust as a child grows. It's assembled from just 9 major components, but it gains incredible structural integrity simply by the sides being drawn tight across the threaded bars.
Then we get to 2003, taking adaptability to its absolute limits with the Mira chair by Studio 7.5. It achieves incredible ergonomic excellence through its highly adaptive Ultramid nylon Triflex backrest. And it proved something important. Extreme, breathable, ergonomic adjustability doesn't actually have to come with a massive luxury price tag. It successfully combined high performance with an accessible cost for the everyday worker.
Next up is Section 4, Pushing the Limits of Form, when technological curiosity drives aesthetic innovation.
So, Ron Arad's 1997 Fantastic Plastic Elastic Chair, or FPE for short, completely eliminates the need for cross struts. How? Well, he extruded a soft alloy frame and then used the rigid polypropylene plastic seat itself to structurally bind the legs together. Arad intentionally used the unique properties of the material to create a really playful, dynamic movement between the side frames. It is literally engineering disguised as art.
Actually, Arad pulled off what was basically a brilliant manufacturing heist for his famous Tomvac chair. He shrewdly used large-scale sculpture funding from a magazine to finance a massively complex CNC superforming tool. He stacked those superformed aluminum shells into a giant, towering sculpture in Milan, generated unbelievable buzz, and effectively got the art world to pay for his mass-market R&D. That paved the way to create an injection-molded plastic version.
If you look closely at that large-scale wave texture on the final injection-molded Tomvac chair, you'll see it isn't just decorative. It's a profound structural necessity. Because mass-produced plastic is way more flexible than the original superformed aluminum, that specific wave pattern is exactly what gives the flexible plastic the deep rigidity it needs to actually hold a human being safely.
And finally, we arrive at Section 5, the Sustainable Design Frontier, rethinking materials for a low-carbon future.
The 2010 Different World Chair represents a massive leap in material optimization. It completely strips away all those clunky, complex dials, relying purely on just 2 passive adjustments and a highly reactive mesh seat to perfectly support the user. It completely minimizes material use while totally optimizing sustainable performance, a real game changer.
Check out that number on the screen, 12.2 kilos. To put that into perspective, that is incredibly light for a high-performance task chair. It utilizes 100% recycled aluminum, proving for sure that supreme ergonomic functionality can actually be incredibly lightweight. By reducing the sheer number of components, it became one of the most sustainable task seats on the market when it launched.
But if we're talking about the absolute bleeding-edge frontier, that's Werner Eislinger's 2011 hemp chair. This is heralded as the world's very first monoblock chair formed from natural fibers rather than petroleum-based plastics. Visually, it perfectly echoes those stacking plastic chairs of the mid-century, but it completely flips the script on the environmental impact of the materials used.
Get this material wasn't even meant for furniture in the first place. It was originally developed for lightweight car door panels. The process compresses a mixture of 70% natural hemp fibers and 30% non-toxic water-based glue under immense heat and pressure inside a special tool. It achieves major eco-credibility through its high performance and the entirely non-toxic nature of its binding agent. While the hemp chair isn't perfectly recyclable just yet, it leaves us with an incredibly exciting thought. As we master these new natural manufacturing processes, and as biocomposites start matching the sheer strength of those mid-century plastics, what incredible, living materials will our everyday objects be grown from next? It's a thrilling frontier for design, and I really hope this explainer has changed the way you look at the chair you're sitting in right now.